a way that we have to extract meaningful information from usually pictures, but it can also be any 2D, like any grid-like structure. So it can be a 2D picture, which is actually just black and white, a 3D picture, which will be a color picture, because we have one color, one channel for each color, so that's 3D. What's the question?
Yes, can we use convolutional neural network for 1D data?
Yeah. I have not seen it used in practice, but I think it's in theory possible. Is that correct?
You use 1D convolution, right?
Yeah, you can use it.
Okay, yeah.
1D convolution.
But I wouldn't know in practice what it would look like. So there are several types of layers in a convolutional neural network, which are convolutional layers, pooling layers, and also, well, there's activation functions which are typically included in the convolutional layer. And the convolutional layer applies a filter to the image. The filter will have as many dimensions as the input of the network. So for example, for a picture, it would be, let's say, a 3 by 3 by 3 cube of values that will be applied to the pixel of the image. Again, the red pixels, the blue pixels, and the green pixels. One time on each series of pixels, and then you move it, and you move it, and you move it. So you sweep the image with this filter, and you take the value. The filter applies an operation called element-wise multiplication, where it takes the first value of the first pixel and the first filter, multiplies it, add it to the next, add it to the next, and you get a value. Yes?
Okay, I have a question. The filters are predefined, or your network is learning?
The filters are learned by the network during training. So as you go through the network, you have multiple times the same layers. So again, one is the convolutional one, and one is the pooling, which is just taking either the average or the maximum value from a series of activations of the pooling, of the convolution, and reduce. So it's a cheap way to reduce the dimensions of the image. Basically, it just takes the average value or the max value. And as you go through it, so let's say you try an input image and you get a classification out of it. That would be probably incorrect before you train the network. So you do back propagation, trying to adjust the values of the filters to better match to try to get closer to the correct classification. And that's in short how convolutional neural networks work. Any questions?
Yes. Sorry, and I can see in this figure. Okay, there are some learned representation in the first layer is different than the second and the third one. Why
Yes.
is it so?
So basically, what happens is on each convolutional layer, the filters learn to extract different features. So in the first layer, they learn the simplest possible features, which are either horizontal, vertical lines, oblique lines. Sometimes it's like a part of a circle, things like that. And then following layers combine those features to form more complicated shapes. So if you have a convolutional network that is trained to detect cats and dogs, you will have in the last layer filters that are a particular part of a face of a dog, specifically in the upper left corner of the image. Like they get super specific like that sometimes. And they get activated more the closer the image is to that specific filter. And again, like the filters at the top, like the further you go in the depth of the convolutional network, the more complex these filters get. But they start from super simple things, which can be just series of colors or lines or edges, things like that. Yes?
Do you decide the type of features, or in the layer what kind of feature will be extracted? Or
No,
the
that
model does it on?
No, the very good thing about convolutional networks is that you don't have to decide which features are meaningful. So one approach you could take is you just try to reduce more and more how many dimensions are extracted from the network, and then you get like, if you compress it all the way down to 3 features, those would be the 3 most meaningful features that possibly exist to determine if there's a cat or a dog in that picture. So you don't know always what you get. Actually, more often than not, you just get a black box. Usually those very pretty visualizations over there are not looked at. Like, you have to do it on your own. There's some extra methods to get what the filters look like. But yeah, the network decides for itself what it's gonna select, what features are gonna be selected. Then maybe you find out you compress the values too, like you compress the search space too much. So 3 features are not enough to understand whether it's a cat or a dog, and you would need more. But you're basically certain that it will filter out all the useless stuff and just keep what's useful. Anything else?
So does the training and testing work the same? So what I understood is that when the network learns, you put the picture through, it goes back until it's labeled kind of correctly, right? But when you actually want to classify it, it goes once through?
Yeah.
Or how does it work?
Yeah, when you train it, you go through, find the error, and back propagate the correction to the error to minimize it. Instead, when you actually test the network or when you're using it in production, you fix the filters are fixed, so you stop changing them and you just run it through once.
So basically, the network, when you test it, searches for specific filters that already are
No,
labeled.
it always uses all the filters that it has produced, and some of them will, like, you have an activation function on the filter, so you apply it, you get this sum. As I was saying, you do element-wise multiplication, and then you sum those values and you get a number out of it. And the higher the number, the more active that filter is, which means you have in the image that specific feature that the filter selects for. So most filters will be 0 most of the time, especially if you use ReLU as a activation function, which sets all the negative activations to 0. You take only the positive values and you keep the values, and the positive ones will be the filters that are active, that have been found in the image, basically. The values have been found in the image, so they become very excited, like neurons in the brain. You keep those values, and you send them downstreams to other neurons neurons, not really, in this case it's just matrices that are filters. But it functions, they get as activated or not activated like it happens in the brain.
But it's binary, or do you get a certain activation for each filter?
Depends on the activation function you use. It's almost never binary, but it's either 0 or small or big. Like with a real function, activation function, it looks like a horizontal line on the negative side of the graph. And on the positive side, it's just a straight line with x equal y, y equal x. That's the most common one, but you can have a sigmoid where it goes like flat, then around the 0 value, it goes from being negative to being, from being -1 to +1, or from 0 to 1. There's a lot of options. It's usually not as simple as binary, but for explanation purposes, it might as well be.
I got a question. Can you also apply CNN for videos, or is it just image recognition?
You can use it for videos as well. And a video will be just treated with as a 4-dimensional input. So the filter, instead of being a cube 3 by 3 by 3, or let's say it will be
Yeah, 4
n times n, which will be your kernel size. So it will be how many pixels you're looking at the time, times 3, because 3 will be how many colors you have in the video, times how many frames the video is long. So it's a very arbitrary shape. It will be a hypercube. Like, it doesn't really mean much to our brain to think about a hypercube, but it is what it is. But you can give it a video as an input. For example, when you want to do semantic segmentation, in self-driving cars, they have an input video that you see. You want to know which part is the street, which part is a tree, which part is a pedestrian or another car. That's called semantic segmentation. You take the input in and then you simplify, you remove all the noise and you just have what is what. And that is done with video and convolutional neural networks. That's all.
Yes, so thank you very much.
Thanks for listening. I hope I was not too boring.
And let's set a break at 3:45.